Welcome to Spaceverse, your portal to cosmic adventures. How can any telescope see a galaxy 33.8 billion light-years away in a universe that's only 13.8 billion years old? It sounds impossible. Yet, thanks to the James Webb Space Telescope, or JWST, this isn't just theoretical, it's reality. The JWST has achieved what once seemed unthinkable, capturing light from galaxies so distant they challenge our very understanding of time, distance, and the structure of the cosmos itself. Since it began sending data back to Earth in 2022, the James Webb Space Telescope has completely transformed astronomy. With its gold-coated mirrors and infrared vision, it peers deep into space and therefore far back in time. One of its most revolutionary discoveries is the observation of some of the earliest and most distant galaxies ever seen. But here's where things get strange. Because light doesn't travel instantly, it moves at about 300 million meters, or roughly 985 million feet per second. We never see distant galaxies as they are today. Instead, we see them as they were billions of years ago. We're looking back through time itself. Now, if the universe is 13.8 billion years old, logic suggests the farthest we could possibly see would be 13.8 billion light-years away. After all, light can't have traveled longer than the age of the universe. That should form a kind of cosmic edge, a limit to how far back we can look, a horizon beyond which no telescope should be able to peer. And since nothing can move through space faster than the speed of light, there shouldn't be a way for a galaxy beyond that point to have any observable effect on us. Right? Wrong. If only the universe were that simple. According to Jake Helton, an astronomer at the University of Arizona and part of the JWST Advanced Deep Extragalactic Survey, also known as JADES, the reality is far more complex. A cosmological horizon, Helton explained, is the maximum distance from which one could possibly retrieve information. There are actually multiple types of horizons, each defined differently depending on how the universe expands or evolves. But the most relevant one here is the cosmological horizon, the maximum distance from which light could have traveled to us since the birth of the universe. That defines the true edge of what we can observe. And in March 2024, Helton and his team announced something extraordinary. JWST had spotted the most distant and ancient galaxy ever recorded, an object known as JADES GSC 14-0. This galaxy existed when the universe was only about 300 million years old. And yet its light has somehow managed to reach us across billions of years. The catch? It's located about 33.8 billion light-years away. That number seems to break everything we think we know. How can we see light from a galaxy so far away when the universe itself isn't even old enough for that light to have traveled such a distance? Wouldn't that mean we are seeing something from before the universe even existed? Not quite. The answer lies in one of the most beautiful, confusing, and mind-bending truths about the cosmos. The universe is expanding. If the universe were static, if everything just stayed where it was, then yes, light from a galaxy 33.8 billion light-years away would take 33.8 billion years to get here. But the universe doesn't sit still. It stretches. It grows. Edwin Hubble first noticed this in the early 20th century when he observed that distant galaxies appeared to be receding from one another. The farther away they were, the faster they seemed to move. Space itself was expanding. Then, in 1998, two separate teams of astronomers made a discovery that deepened the mystery. The expansion wasn't just continuing, it was accelerating. Some unknown force was pushing galaxies apart faster and faster. That mysterious energy became known as dark energy, a name that reflects how little we still understand about it. Throughout the universe's history, there have been three major eras of expansion. The first was the inflationary epoch, immediately after the Big Bang. In a fraction of a second, the universe's volume ballooned by a factor of 10 to the power of 26. That's a 1 followed by 26 zeros. Imagine your fingernail growing from its normal rate of 1 nanometer per second to suddenly stretching 10.6 light-years long. That's how extreme it was. This period was followed by the matter-dominated epoch, starting around 47,000 years after the Big Bang. The universe cooled just enough for quarks and gluons to form protons and neutrons, which then combined with electrons to form hydrogen atoms, the building blocks of stars and galaxies. Expansion slowed during this time, allowing matter to clump together under gravity. But around 10 billion years after the Big Bang, something changed. the expansion began to accelerate again, ushering in the dark energy-dominated epoch. This is the era we live in today, an age defined by invisible energy pushing galaxies apart faster than ever before. So what does this have to do with Jade's GSC 14-0? Because of the universe's expansion, the light from this galaxy has been traveling for about 13.5 billion years. But as it journeyed toward us, space itself kept stretching. That means the distance between us and the source of that light grew larger during its trip. By the time the light arrived, the galaxy had moved much farther away, so far in fact that its current proper distance is now 33.8 billion light-years. In simpler terms, JWST is seeing Jade's GSC 14-0 not as it is now, but as it was only 300 million years after the Big Bang. Its light has taken nearly the entire age of the universe to get here, but the galaxy has kept receding the whole time. According to Helton, the true edge of what we can observe, the cosmological or photon horizon, is about 46.1 billion light-years away. Anything beyond that is currently unreachable to us. Luckily, Jade's GSC 14-0 still sits comfortably within that limit. To make sense of these immense distances, astronomers use two types of measurements: co-moving distance and proper distance. Co-moving distance ignores the effects of the universe's expansion, representing where the galaxy would be if space hadn't stretched. For Jade's GSC 14-0, that's 13.5 billion light-years. Proper distance, however, includes the expansion, which brings the figure to 33.8 billion light-years. It's mind-bending but beautifully logical once you understand how space behaves. But here's the bittersweet part. We live in a lucky era, an era where we can still see these distant galaxies. The JWST can detect Jade's GSC 14-0 because it was once causally connected to us. That means light from that galaxy could still reach us, even if just barely. But as dark energy keeps pushing the universe apart, that connection won't last forever. Helton explains, any observable galaxy must be within the particle horizon and must have been causally connected with us at some point in the history of the universe. That's true for Jade's GSC 14-0 today, but not forever. As space continues to expand, galaxies like this one are moving away faster than light, not because they're breaking the laws of physics, but because space itself is stretching faster than light can traverse it. In the far future, any signal they emit will never reach us again. This doesn't violate Einstein's theory of relativity, because the rule that nothing can move faster than light applies to objects through space, not to space itself. The fabric of the universe has no such restriction. Fast forward 2 trillion years into the future. Earth and humanity will be long gone, perhaps even the sun extinguished. Whatever intelligent life may exist then, if any, will look into the night sky and see nothing beyond our local group of galaxies, a small cluster spanning only about 10 million light-years. Every distant galaxy, every ancient light now visible through JWST will have faded beyond reach, separated from us forever by the relentless acceleration of the universe. It's a haunting thought. We live at a cosmic crossroads, the only window in time when the universe allows us to glimpse its most ancient secrets. Future civilizations will never have this view. That's why telescopes like JWST are so vital. They're not just tools of science, but time machines, giving us fleeting access to an era that will soon vanish from view. Jake Helton and the Jade's team know this better than anyone. Their work revealing Jade's GSC 14-0 and galaxies like it is more than research. It's an act of preservation, capturing a piece of the universe's infancy before it's lost to cosmic expansion. Working with JWST and the Jade's collaboration has been incredible, Helton said. Writing papers about science with JWST, like my recent one on Jade's GSC 14-0, has been the most rewarding and exciting experience of my research career. And for us here on Earth, under our tiny patch of sky, it's humbling to realize what those papers represent. The story of a universe still growing, still changing, still defying our expectations. So the next time you look up at the stars, remember, some of that light began its journey before our planet even existed. And thanks to JWST, we are finally beginning to understand just how far and how long that light has traveled to reach us. And that's it. The universe is expanding, and galaxies like Jade's GSC 14-0 are reminders of just how far we've come and how fleeting our cosmic window truly is. One day, these ancient lights will fade beyond our reach. For now, JWST lets us witness the dawn of time itself. Thanks for watching, and if you love exploring the universe's greatest mysteries, don't forget to like, share, and subscribe. This is Spaceverse, where we look deeper into the stars to understand the story of everything.